today's webinar. We appreciate you all being here, and we see people continue to be joining, which will be great and much appreciated. My name is Peter Zollo. I am one of the co-founders of Collaborata, the market research marketplace. Our aim is to get important research studies like the one we're discussing today funded. We do that in a number of ways, including bringing a like-minded group of people together like you to share ideas, to launch critically important research, as well as the results and the cost. Collaborata is a US-based company. We're actually in Chicago, which is the home of the very soon-to-be former President of the United States. But before we begin, a few quick housekeeping items. We've allotted a total of 45 minutes for today's session, which includes a nice lengthy Q&A. You'll all see there's a chat feature on the bottom left-hand side of your screen. So right at the bottom, you can type in at any time, including questions or comments, and we will refer to those during the final 15 minutes, which will be a Q&A session. And assuming that everything works, which it should, there will also be a recording available of today's session for you to share with other members of your team. So just please email us info@collaborata.com to request it. We'll also send it on out. So with that said, let me please introduce you to today's topic and our presenters. The three companies presenting this webinar today, RTT, the Mobile World and Policy Tracker, have together undertaken a broad cross-section of research and consultancy projects for the mobile broadband industry and satellite industry. The tool involved in all four prior generations of cellular radio, observing and analyzing the impact of spectrum allocation and standards on industry profitability and competitive positioning and related impact on regulation and competition policy. So how do these companies envision the emerging scenario today? They argue that there's a growing recognition at the engineering level that 5G, the fifth generation of mobile broadband cellular technology, can only be successfully deployed into spectrum presently used by the satellite industry K-band and into spectrum that the satellite industry would like to use in the future, E-band. That's already creating substantial tension, both in terms of access rights and potential coexistence issues. The preparations for the World Radio Congress in 2019 already confirm that this is likely to be an adversarial process and an unpromising start for the collaboration needed to ensure the future economic stability of the global telecommunications industry. The success of 5G will be critically dependent on motivating the satellite industry to share their spectral and space assets. What are the business models that might enable this to happen? Who are going to be the winners and who are going to be the losers in this process? So three subject specialists will take us through the next 30 minutes. Between them, they've written 6 books on mobile telecommunications and hundreds of study reports spanning 30 years of industry transition. Jeff Verrill from RTT will discuss issues of relative scale coupled with the impact of technology innovation on the mobile broadband industry and satellite industry and what this means for longer-term profitability of these industries and their associated supply chain. John Teitzel from the Mobile World will discuss debt ratios and cash balances. Martin Sims from Policy Tracker will explain the study methodology and research process, but please note he's also a subject expert on competition policy and auction theory, so he'll no doubt chime in as well when we get to the Q&A section. All of us together, I will note, will try and convince you that it would be exceedingly useful and worthwhile to invest in this critically important piece of research. So with that said, let me please introduce Jeff Verrill from RTT to take us through the beginning of today's presentation.
Thank you, and hello everybody. We have a dog on the attendee list who barks occasionally. We've no idea whose dog it is, but we're hoping he barks at the right moments. So let's see how that works out. Actually, this is on the first slide. We've got a picture on the first slide which is very topical. You've probably seen it in this week in the trade press. It's discussed the successful launch by SpaceX of the next bunch of Iridium satellites. I can't remember if it's 10 or 11 satellites, but essentially the idea of getting 10 or 11 satellites of reasonable size up into space on one lift, so that's one takeoff, and then getting that rocket back onto firm ground to be used again is pretty remarkable. And it kind of makes the point that our team at RTT, we've traditionally focused on the mobile broadband industry, always had an interest in the satellite industry, but not to any great depth. And for the last 3 or 4 years, we began to think, hey, we've really got to begin to understand how the satellite industry is developing, especially at technology and engineering level, and actually how that's changing the business model in the satellite industry, and why that's important for the 5G community as we try to transition from existing 3 and 4G technologies, and indeed 2G technologies, to a promised future of economic high data rate mobile and fixed broadband via wireless wherever we are in the world. So that's really the subtext of the presentation today. So let's move on to the next slide. What do we know today? Well, first, let me explain a little bit. RTT, we're technology economists. We study and analyze the technology economics of the mobile broadband industry, it's a subset of the telecoms industry. My colleague and RTT co-founder, Roger Belcher, is with us today. My specialist background is on system level issues. Roger's an RF design specialist. So if you've got any knotty RF design questions you want to ask, he's the man. We spent our first 20 years at RTT studying the technology economics of analog and digital cellular. From 1982 onwards, we spent the last 10 years focusing on the technology economics of the 700 megahertz band. Very privileged to work with AT&T back in 2007, undertaking engineering due diligence on their 700 megahertz Spectrum bid, and subsequently for Vodafone Global on a similar assignment. We're very absorbed by the impact of Spectrum and technology choice on device cost and performance. That's user or IoT device cost and performance. And we've always had this sort of feeling, and we hope you've proven this over the years, that user device cost and performance is a really dominant, underestimated factor in network economics. It can destroy business models if you don't get that side of the equation right. And that's true. It's true for the mobile broadband industry as it is for the satellite industry. Now, if we think about the 700 megahertz band, we regard that as analog for what is happening today. And I described it in the past as the battle for broadcasting bandwidth. The TV industry and the mobile operator community have sort of worked against each other, had endless discussions, debates about coexistence and access rights, compensation, relative value, value ownership, and the whole auction process. I think we've got Peter Couch in the attendee list today. Peter worked for the Digital Television Group and for Arkiva and did a brilliant job advocating on behalf of the digital TV industry, defending their interests effectively. Brilliant job. And he's now gone to EchoStar, and he used to do the same thing for the satellite industry, and I'm sure he'll do a very good job of doing that. So it's completely understandable that the 5G community wants something which the satellite industry have. The satellite industry are initially and understandably reluctant to share their space assets and spectral assets. Why should they? And part of this study is to try and surface some of the hidden motivations in the supply chain and mobile operator chain and in the satellite operator chain, to see some of the commercial dynamics and technology dynamics, how they and how that might actually provide a foundation for some collaboration in the longer term. That's through merger and acquisition or whatever. So we might also consider that the UHF debate is by no means finished yet. I mean, it's just all it's done is extended itself down to the 600 megahertz band. And there's a school of thought that 5G ought to be deployed into 600, 700, 800, 900 megahertz, the sub 1 gigahertz band, and L band, and S band, and C band, which is essentially the same spectrum that we're working in at the moment. And the satellite industry would, I think, applaud that. So, well, why do you actually need to go above 3.5 gigahertz? Indeed, why do you need to go into 3.5 gigahertz? Because there's plenty of satellite TV there and radar. Why don't you stay where you are, for heaven's sake? And My response to that is, well, the difficulty about that is you can't really deliver anything substantially, well, anything different enough in 5G in the sub-3 gigahertz band. You can't get enough differentiation. There's no real economic differentiation you can deliver. Part of the story is, well, those lower frequencies are better for bigger cells, and you maybe need bigger cells, get rural coverage, but you can't get the data right. That's the major point. You haven't got the bandwidth there to get, it's extremely problematic. These lower frequencies can deliver range, but they don't have the bandwidth to deliver range and high data rates. And also, if you try and get directivity on your antennas, and you really need directivity to get some gain on your link budget, then you end up with very large antennas that create wind loading problems on base stations on Mars. And of course, the lower frequency antennas that you have in user devices and IoT devices are pretty inefficient. You don't actually get the gains you expected. And the other Achilles heel, which I think drives the industry towards the spectrum that is presently used by the satellite industry, is energy consumption. When you think about present networks and user devices, they send most of their RF energy in the wrong direction. And this creates necessary of coexistent costs, reduces capacity, increases the network energy bill, and you translate macro to micro to picocell, you can see your energy cost increasing. That's partly because of handover, it's partly because of signaling, there's all sorts of reasons why that happens. From a user perspective, that decreases user value because you get poor range performance, you get short battery life. It's a bad place to be. Also, energy costs are absolutely in emerging economies where you've got diesel or solar or wind power. It's often the only available energy source. Emerging economy markets are, we would argue, absolutely critical to 5G economic sustainability in the longer term. So two things: 5G cannot be predicated on ultra densification, it's not going to work commercially, and it can't be predicated just on developing economy markets. It has to have global scale. It has to be able to scale to large radii, sell in cost terms to access those 2.5 billion disconnected, the markets in Central Africa, the markets in Central Asia, the markets in Latin America. So, what does the satellite industry have that the 5G industry needs? Well, spectrum is one, we'll cover that just in a moment, but it also has a number of technology innovations that are important to us, one of which are narrow beamwidth antennas. In the satellite, they're often described as fractional beamwidth antennas. They're defined as antennas with a beamwidth of half a degree to 1.5 degrees. Now, at Ka band or E band, that gives you an isotropic gain of roughly 40 dBi, which more than overcomes your propagation loss at those higher frequencies when compared to lower frequencies. And just to give you a contemporary example, terrestrial military radio systems today at 70 gigahertz achieve 60-kilometer line of sight free space range. Doable, expensive at the moment, but doable. Okay, so now the trick, the way that's done, essentially, why do the satellite industry use fractional beamwidth antennas? They also use wide beam antennas to deliver satellite TV as well, but if they're delivering to specific areas, and they use fractional beamwidth antennas to give them geographically specific coverage. You're concentrating your RF energy onto a small area. The 5G reinvention or repurposing of that is essentially the same thing, but you're trying to get user-specific beam coverage. So you've got beams going from the base station to the user and back, and going to 1.5 degree beamwidth antenna. The reason for doing that, and it is the key differentiation between 5G and 4G technically, is that you get two combinations. You get spectral efficiency and you get power efficiency. It is extremely difficult with all present technologies, 1 to 4G cellular, to combine those two. You always trade off in-band performance against out-of-band performance. It's kind of one of those traps you cannot get out of. Fractional beamwidth antennas are one way of doing that, and they can only really be successfully deployed into the centimeter band and millimeter band. So there we go. that's the context of this first slide, really. So it is our premise, and we've got to prove this, but it's our premise that technology innovation is, as it says on the slide here, read the slide, Jeffrey, for heaven's sake, reducing capex and opex in the satellite industry. Now, there's dozens of examples. You've got launch innovation. We talked about SpaceX. That's fantastic and amazing. You've got electric satellites. They've been around for years, but they're getting better and better. You've got the fractional beam antennas, which I've waxed lyrical about. You've got some really interesting innovation coming in the way that constellations are used and mixed together. You've got companies like O3b, now part of SES, that have a combination of MEO and GSO satellites. And there's several things that happen there. One, you reuse your spectrum, so you can use the same band from both constellations. You do that by getting angular power separation, which is exactly what you're going to get in 5G. Right? So you can envision quite soon, because it's happening in the military sector already, the combination of LEO, MEO, and GSO satellites, low Earth orbit, medium Earth orbit, and geostationary. If those three together, and you see the combined coverage and link budget you can get from those three different constellations or constellation types, you get a very interesting proposition for both terrestrial backhaul and terrestrial coverage, particularly for what we describe as Middle Earth. That's the Middle Africa, the Middle of Asia, the Middle Latin America. Those bits that are expensive to get to if you're Vodafone in Africa, in sub-Saharan Africa. So there's a lot of innovation happening in terms of constellations, and a lot still could happen in the future. In a way, there's been mixed experience so far. So, well, surely the logical corollary of that then is that you take those three different types of satellite constellations, you integrate them with 5G, and wow, off you go, because you're in the same spectrum. You're either in the centimeter band or in the millimeter band. You've got the same spectrum. You've got the same channel band plan. If you look at the channel band plans that are implemented into, say, 28 gigahertz, 38 gigahertz, and then the band plans either side of the radar bands, 70 gigahertz, 71 to 76 and 82 to 86 gigahertz, they are precisely what is needed for 5G. They're 25 to 250 megahertz channel rasters. In the 70 gigahertz band, you've got 19 250 megahertz channels, 135 megahertz guard band. Absolutely done and dusted. Now, at the moment, that's used for fixed wireless backhaul. It's used by the satellite operators. They're beginning to use millimeter band as well. So it kind of makes technical sense to say, well, why don't we think about putting all those things together? We've got scale across different markets. We've got scale across the spectrum. We've got to do something about the standards, because there's no meaningful standards link between the work going on the 5G standards, the 3GPP, release 15, release 16 stuff, and the satellite industry. Partly because previous attempts to that have not worked very well. We tried it with IMT 2000 in the late 1990s, and it never really went anywhere for a variety of reasons. And also, hybrid terrestrial satellite networks have not had a great outing, because companies like LightSquared have failed initially financially, and companies like Thrive have been more effective. So those are sort of there's a technical argument of why you bring those two together, three things together. There are commercial arguments as to why they haven't worked in the past. So well, what could motivate? What would finance? What would lubricate a coming together, a convergence at technology level and engineering level? Which moves us onto this slide. Someone's moved me onto the slide. That's a hint, I think, probably. Well, we think it all comes down to relative scale. And I've just thrown together a few examples here of the relative scale of the mobile broadband industry and its supply chain, and the satellite industry, the GAFA quartet, which is Google, Apple, Facebook, and Amazon, in fact, Microsoft as well, the automotive industry, and the test equipment guys. We've got a few test equipment guys in the room. And when you look at companies like AT&T, Verizon, or Vodafone, AT&T is $150 billion, haven't included, oh, thank you, Peter. I haven't included China Mobile here. China Mobile is about 100 billion. China Mobile employs 440,000 people. For heaven's sake, these are mighty companies. Then you've got the vendors, Ericsson, Nokia, and Huawei, of course. Huawei now claims to be bigger than Ericsson. It's probably true. Huawei spends more money on R&D than Apple. Huawei's got a handset business, which Ericsson used to have. Nokia's going back into the handset business. It's a highly consolidated supply chain, highly efficient supply chain. It's not just, I know we've got Ericsson, Nokia, and Huawei on the call. It's a highly integrated supply chain which spends 12 to 15% of its revenues on R&D. And behind them, you've got massive device vendors like Samsung of the same order of scale, $160 billion company, 280,000 people employed in Samsung. Move down to the satellite industry, and you're 2 orders of size smaller. I'm not saying that's a bad thing. It's just reality. So you look at any of the sats, Inmarsat, Intelsat, Eutelsat, Arabsat, whatever, any sat, every sat. You're talking about 1.5, 2 billion as a turnover, and maybe 1,000, 2,000 employees. Now that's a virtue as well as a disadvantage. It's a virtue because you can be much. You haven't got the cost base for a start. And behind them, they've got this massive muscle in terms of satellite system vendors, like Boeing and Lockheed and Northrop and Raytheon and Harris, but they're geared up to supply the DoD market. So it's a very different market to the market that Ericsson, Nokia, and Samsung and mobile broadband community are addressing. I mean, look at Lockheed's biggest product is the F-35, which is what, $280 billion over budget now. It's a very different product from a smartphone. The other stakeholders are the Gaffer Quartet, and the Gaffer Quartet is the interesting thing we want to move on to now. I'd like to introduce my friend in a minute, John. Don't start quite yet, to talk about the operator net debt. And does that mean that this is going to change the dynamics of the industry? Off you go, John.
Okay, thank you, Jeffrey. I hope everyone can hear me. I'm John Tyso. I come from a company called The Mobile World. My background is financial. For about 25 years, I spent my time as an equity analyst in the City of London, doing first tech companies, then tech and telecom, and then for the last 20 years, telecom only. That came to an end back in 2003 when the bank that I worked for went bust. But that was okay because it gave me the chance to work for myself. And at the Mobile World, we specialize in providing all sorts of financial and operational data and information about the global telecom industry. And this is just one piece of it. My 2 slides highlight a single aspect of the asymmetry that Jeff alluded to, specifically the difference in debt levels across the industry and what that means in terms of financial firepower. This first one is the 10 or 11 most heavily indebted telcos, and you can see that the borrowings have been rising steadily. The 2013 blip was occasioned largely by Verizon's takeover of Vodafone's American properties, but that spike apart, the overall trend is clear. Taken as a whole, the operator industry owes about $1.1 trillion net, and that's equivalent to a debt-equity ratio of about 85%. I think with increasing M&A activity, then this debt level is going to continue to rise, both in absolute terms and proportionately. Now, by contrast, this group, the Internet Group, Gaffer, as Jeff said, plus a couple of large vendors, they've got well over $250 billion in net cash. If the regulator were to permit it, this is more than enough to buy the satellite industry twice over, just for cash. Were these 6 companies to gear up to the same level as borrowing as the operator industry, they'd have about $650 billion to spend. That's enough to buy the largest dozen or so European telcos, or they could reassemble the 84 Bell system, put back the world's largest monopoly into one piece, or they could do more or less anything else that they wanted to. It's a brief point that I think that we should assume that the traditional operators aren't necessarily going to have everything their own way in the race to 5G. I'll hand back to Jeff.
Yes, it's mind-boggling, those two slides. So what are we trying to get out of the research? Well, the goal of the research is to understand, is the satellite sector undervalued or overvalued? There are risks, and one of the risks is that you put more and more constellations up there, and they've got low fill rates. Okay, that might become very good value as takeover targets. There's cash, as John explains, swirling around in the OTT market in the web scale community that could go in their direction, although that's not where they've traditionally spent their money. Companies like Google have traditionally invested in access, but they've got their balloon projects. Facebook got their drone projects. Facebook have their Internet Org project into Africa, and even companies like Amazon ships Kindles into Africa, for instance. So they understand these emerging economy markets. So we need to understand the motivation of new players, including the GAFA players, and whether they might come in and unsettle our industry. And we also need to look at companies like OneWeb that are coming in with mass production techniques in microsatellites that can also change the industry. OneWeb are trying to do they are doing a reinvention of teledesic. And if you remember that from 1998, 1998 with Craig McCaw, an amazing kind of Elon Musk type reinvention of the satellite industry. So there's a lot of things to analyse and look at in this sector in terms of the research study. We want to look at the relative long-term value of developed and developing economy markets. The demographics are just incredibly persuasive. There's going to be another billion consumers in Africa by 2050, and they're going to be rather wealthier than we think at the moment. So you can begin to see that if you can find economic ways of delivering low device cost and low access cost to what I call Middle Earth, 58th to 48th parallel, then the telecoms world is going to look very different by 2050. So device network costs, really important. What is the required rate of rate decline? So you think about the satellite industry today can get $3,000, $3,000 per month maybe for access, and you can see satellite terminals that cost close to $3,000. Well, to get into emerging economies, you probably need two or three orders of magnitude. So you probably need about $3 per month access cost and about $3 for a device cost. So an enormous difference. In the middle, we've got the mobile broadband community that maybe charges about, let's see, $50 per month in terms of access, and you've got devices about $300. Now, if you went down a very fast rate of rate decline to get into the emerging economies, what on earth would it do to the satellite industry? They would be uncomfortable about seeing that rate of rate decline. So those are sort of issues that we'd really like to bottom out in this study, described as the quantified impact of technology and commercial innovation to supply chains and other stakeholders. Include the automotive industry in there, radar, the military, and space radio. I haven't really had time to talk about the automotive industry. It's fascinating, but there we go. Let's move on. I'd like to move to Martin now. Now, Martin's going to take us through the methodology that we're going to use to actually capture this, capture the right metrics in the study. Martin.
Hello there. I'm Martin Sims from Policy Tracker. And if you don't know us, Policy Tracker is best known for a newsletter which we've been doing for about 12 years now, which analyses regulatory and industry trends among Spectrum users. So we have about 1,000 subscribers in that field. That's the basis of our business, but we also do a lot of bespoke research for companies as well as public research. So we've done research for regulators, for mobile operators. We've published about 20 research reports that are available to the public. And we're currently doing a research project for the European Commission. So, which involves interviewing people in the mobile sector, the telecom sector, potential 5G verticals, and through those interviews, drawing out conclusions which relates to regulatory questions and relates to industry trends. So we have a lot of experience in interviewing people and getting from those interviews information that's going to be useful to answer research questions. So the aim of this research is to carry out about 30 in-depth industry high-level interviews covering mobile operators, satellite operators, vendors in the mobile and satellite community, military radio, radar, automotive radar, so car connectivity stakeholders. And what we'll be looking for is people with an ability to give us an expert view on financial and engineering and technology issues. We're quite familiar with lots of these people, having carried out this kind of research for the past 10 years or so now, and doing it almost every day for our newsletter. In order to get a good spread of responses and to try to give a sort of global answer to this question, we're going to make sure that we interview people from the full range of global companies, so the three regions covered by the ITU, Europe and Africa, Asia and the Americas, and making sure as well that we're interviewing a range of companies, including the biggest vendors and operators. And in the satellite community, we also want to make sure that we cover the range of different orbits there, and of course the range of bands that are used, including Ku band and Ka band. So the aim is to have a wide geographical coverage as well as a wide industry coverage. And then I'll hand back to Jeff.
Thank you. Okay, I better move along here because we're going tight on time. Results analysis. Well, what we're trying to get at is spectral asset, space asset, terrestrial asset value, technology positioning, return on investment ratios through the supply chains. The way that risk distribution shifts in the supply chain, really important. It's like a poison chalice that gets moved around. The population, demographic and geographic coverage, present and future evaluation. That's an old term really, because we're also describing IoT devices that aren't technically subscribers, essentially it's device valuation. Relative debt ratios, the stuff that's fascinating stuff that John analyzes every day, and the gearing of the supply chains and their offerings to customers is we see as absolutely crucial, and needs quantifying and analysing in the context of the technology changes that are getting place. So the results analysis, likely scale of the present satellite sector undervaluation, I think it is, the implications for 5G and future satellite constellation return on investment, apart from anything else, if you've got low fill rates, you need a collaborator that can solve that problem for you. So if you've got Amazon shipping Kindles into Africa, or if you've got Google, the one thing they've got is cash, and they've got customers. They have two unique qualities that are together useful. Then you've got the relative position, the other stakeholders, the automotive guys, of course, enormous. I think VW spends $12 billion per year on R&D, a lot of it on connected cars now. I think we have Jaguar Land Rover in the audience. Tom, I hope you're there. Very centre of amazing innovation in the UK on car connectivity. And we have this complete logic about moving backhaul. Backhaul's a real consumer to 5G, incredibly expensive. Christ heaven's sake, move it all in band. Have it in the same band. You have the same RF hardware across backhaul, across mobile, across Node Bs, across LEOs, across GSOs, across MEOs. You've got everything together. Well, that's what we think, but we might, of course, be wrong. That's what we're trying to prove. What you get a formal detailed report, you get a web-based publication, you get us in person if you buy multiple shares. God, how can you possibly resist that? And importantly, in terms of the process, we've done this dozens of times before, we get a draft out at the end of, it's a 3-month process, you get a draft at the end of the first month, we share the draft, we go through the draft line by line with you, we refine it, you get the second draft at the end of the second month, and you get the final product at the end of 3 months. That's the way you do it. And why you should co-sponsor this project? Well, this is a, come on chaps, this is $1 trillion industry. It's in transition, it's got unique risks, it's got unique opportunities. They need to be precisely valued. Some of the things that need to be worked out are you know, how do you get your device costs down so that you can get out of this saturated market problem? I don't know how many blogs I read that say 5G is doomed, it's doomed, it's doomed. They say it's never going to reach the price point. It's only going to reach the price points to open up new markets, to get out of the oversaturation issue in developed economies by hitting device points and access costs that are several orders of magnitude lower than they are today, both in the broadband industry and satellite industry. How on earth do you do that? Who's going to do it? Are the disruptors like OneWeb that might do it? So that's why M&A could be a major factor. We need to know who will own future industry value. So that's about it, really. It's time for questions. Peter, actually, it's time for you, I think.
So thank you, Jeff. Appreciate it. So let us get to questions just very quickly. I think important information on how to actually become an investor in this, how to be one of those who sponsor this. So go to collaborata.com. You will see this particular listing of many projects. The second from the top today is the project we're discussing, and that's what we do today. You'll see very quickly how to purchase the study. You will see a button that says co-funded. As you can see, the co-funding price is $50,000. You now understand not only the level of analysis that this will be providing, but also the deliverables that Jeffrey just described. And by the way, if you refer this to somebody else who then comes along and becomes a co-funder as well, you will be credited with a 10% referral commission to your actual funding price. So it's a way to save a couple of dollars. So we are now to the Q&A. Jeff, I will let you take this over here.
Okay, well, we're open to questions from the floor. I hope there are some.
Yeah, everybody may type questions way below there. And I think there were a few, Jeff, that you were handed at the beginning. If you want to, perhaps, or Martin or John, if there are any points that you would like to clarify as well, this would be a great time to do so. We've got just a few minutes left, so our timing is great.
Okay, so can I ask if anyone has questions? Are people online so they can talk to us on audio, or do they need to type?
They should type. So you see, there's one now who's asking about the time schedule for this project. Jeff, do you want to talk to that?
Well, it's a 3-month project. So, and if someone presses the start button, they will start. Doesn't mean to say we're not doing other things at the moment, but essentially it's done and dusted in 3 months is the target.
So the sooner we start, the better, and that's really the purpose of today's all of us coming together, is to make sure we find co-sponsors so we get this launched. So that's a great question. Any time schedule? Any other questions, Jeff? For Jeff or John or Martin? Any final comments, Jeff?
Well, yes, I mean, I could talk for days about this, but I mean there are several other trends. The automotive industry is really important, and one I want to keep because the automotive industry both arguably, well, it certainly needs better coverage. It certainly needs about an extra 15 or 30 dB of link budget, which is completely sustainable in existing 5G business model. So that needs to be addressed. So that's quite important. Also, the US, as always, is doing things differently. Doesn't mean they're doing things wrongly. I think they're actually doing some really interesting things. If you look at AT&T and EchoStar, you look at Verizon and Viasat, you look at what Facebook is doing with Eutelsat, they're all having discussions about the 28, 38 gigahertz band. 28 gigahertz band isn't supported by ITU, but the band plan is absolutely ideal. There's no question about it. So, if you've got any kind of common sense, don't look at any other bands than the deploy 5G. Also, of course, you'll see that the 5G TF, that's the 5G Technology Forum, is concentrating on fixed access as the initial deployment of 5G. Now, again, that is completely sensible. The way to think about 5G is it is a progressive point-to-point network. It's not working in the traditional way that 4G, 3G, 2G, or 1G networks work. From a user perspective, you don't notice the difference, but essentially you've got beam illumination from point to point, and you've got beam handover, and that's the way that you get your isotropic gain. That's the way you get your large cell coverage in rural areas. That's the way you break out of the problems the existing 5G business model has. So I think the US is doing some really interesting things, both in terms of technology innovation, both in terms of the way that the operators are seeing spectrum. And the
So
final thing is...
Yeah, we have a couple more questions for you there, Jeff.
Okay, so in the US, there's large spectrum accelerator SoC have failed to sell. Yes, I agree, and I think one of the reasons for that is that it's really hard to get devices, especially small form factor devices like smartphones, to work effectively in those lower bands. Just because you don't have the size of the antennas, you haven't got the size for you can't get the ground plane, so you're going to lose about 7 or 8 dB of your link budget. So what you've gained, you've lost. Also, there's an expectation of value there, which is completely disproportionate. So 600 megahertz is not actually what you want. And in a way, you can argue that you've got a bit of a spectrum glut below 4 gigahertz. You're not short of spectrum in the mobile broadband industry. You're short of power. You need to solve power. The people that have solved the power problem are the satellite guys. The reason they've solved that is that they've always had to solve that because their power is very expensive in space, and power on the ground is expensive as well. The uplink budget has always been a problem in handheld satellite devices. So they've had to look at ways of solving that problem far ahead of the mobile broadband community that hasn't had that same problem. And yes, 5G is an overlay technology, but 3.6 gigahertz is hot. Well, it is hot in space. The reason it's hot space is you've got TV in a lot of emerging economy markets. You've got radar you've got radar there, and I can't see the C-band, as we call it. Let's call it 3.4 to 3.8. It's so different in terms of the way it's being deployed in the States and the rest of the world. You've got many countries that cannot be deployed because of existing radar or because of existing satellite TV. To say that satellite TV is just going to disappear from C-band is ridiculous. It's growing. You've got companies like EchoStar, a business model on C-band, and a lot of satellite operators for years have done well out of C-band in the TV space. That is not going to disappear. So I think C-band, the 3.4 to 3.8, has been grossly over promoted. WiMAX restructuring undergoing. Yes, I think we need one physical layer. It's like Tolkien. We want one ring to rule them all to bind them. We need a physical layer for 5G and everything. Leo, DSO, whatever moves, let's make it the same. Because it's completely sensible to have one RF hardware platform that is common across multiple technologies. It's the only way in which you're going to get global scale. It's the only way in which you're going to get device costs down to a level whereby you can begin to ship into Africa and Asia and Latin America and deliver added value to those markets. Virtualization. Oh, okay, yes. Not a fan, really. I think we ought to discuss this offline. Yeah, I don't see that as a way of virtualization. I would say is abstraction. I don't see abstraction as actually it hides complexity. It doesn't solve it. But there we are. That's I have rather strong views in that area.
I noticed there was a question earlier from Cecil Amil. Hi, Cecil. About any reason to pick the automotive industry rather than other 5G verticals, and no, not particularly. I think we probably just turn to that possibly out of familiarity. Although there is, it is certainly a huge industry with a large financial backing behind it, and I think that's one of the reasons why we were interested in it. And I think one of the points of this study is to try to look at some questions about spectrum which are often not considered in the context of the financial size of the industry. and sort of consider those with a financial elements to the analysis as well.
And the automotive industry has a lot of money, and it's also quite highly indebted in places, and it's got assets, and the assets are things that move that could easily be base stations and repeaters and relays. So whether we think of the automotive industry, it also includes tractors, also includes lorries, and includes a lot of other things other than cars. Murray, 5G cells aimed at 100,000 meters, yes, but that's completely wrong, isn't it? It's unsustainable. I think the industry is going in completely the wrong direction. 5G is completely unsustainable unless it can scale to ultra-sparse networks. Unless it can do that, it is not going to be financially sustainable. There's no way out of that. And so the present obsession with network densification is a disaster because it increases the power inefficiency, it increases capex and opex. So we started this whole presentation on the premise that technology is reducing cost in the satellite industry. It's increasing capex and opex in the mobile broadband industry. It's a real problem that needs to be solved. Large cells have no capacity. I disagree. If you've got a large cell and you've got fractional beamwidth antennas, you've got half-degree beamwidth antennas, then you've got all the capacity you need. I believe automobile, that's good fun, this, isn't it? I believe automobile guys are ready to jump to compete with internet guys for network densification using VRAM. Yes, that's possibly true. I mean, the only caveat I've got there is the automobile guys are hopeless at working with each other. I mean, you know, the idea of General Motors actually working effectively with Ford or with Jaguar Land Rover, for heaven's sake, seems, I mean, I know we find it hard to get together in the mobile broadband industry, but for heaven's sake, the auto guys are hammer and tongs against one another. So I think there's some sort of commercial issues there. Oh, large cells have large latency. Yes, but David, you know, an awful lot of applications to the internet are actually pretty relaxed about latency, and as you know, we've had this argument before. Actually, latency isn't the problem; it's the second-order effect, which is the variability of the latency. And if you've got some combination of terrestrial LEOs, MEOs, and DSOs, you've got the whole latency issue wrapped up from low latency to high latency where you don't need it. So yeah, I mean, it's addressable. No, I disagree, Mark. I mean, I think you have to look at the work that Nuke Wireless are doing, and you know, you've got about an extra half dB of propagation loss there. Okay, I take your point because I know this is your point, but you've got a lot of absorption from surfaces. You've got surface absorption. The guys in New York, that's Ted Rappaport and his friends, you know, they're doing some really interesting work on waveguide effect in urban areas. And also, if you think about those military systems where you're getting 60-kilometer line of sight, decent coverage at 70 gigahertz, yeah, the stuff works. The reason it works, of course, is they're using incredibly exotic components. They're using gallium nitride PAs from Northrop Grumman. They're using low noise LNAs. They're using some amazing material innovation. We can do that. Hang on, I'm going to quote an ex-president here. Yeah. No, I disagree. There's perfectly like we have perfect line of sight in a lot of applications. So if you think about, you know, I think we think into an urban mindset. The urban problem is one that needs to be solved. The urban problem can be solved to an extent by line of sight. This is why I say it's a progressive point-to-point network. Just rethink our consideration of 5G. In a rural environment, it depends on having high towers. You've got to have high towers. You've got to have a lot of directivity from those towers. Think back to Tolkien. You know, it's Sauron and his tower of whatever it is. You know, maybe we need to do something about Tolkien. Maybe Tolkien has this whole industry wrapped up and tied it up for us. Oh no, Maury, we're going to go on. We're going to bore people soon. No, I disagree. So, Maury, I think we're going to have to agree to disagree on this topic. I think the access problem can be solved. I think it has already been solved in the military. I know it's been solved in military systems at a vast price. There's no reason why we cannot bring that technology down from space and deploy it at ground level. Yes, Upco. Backhaul is a mesh word, as in defence. Yes. Well, backhaul is mesh. Progressive point-to-point is effectively what I'm saying is that the traditional separation between mobile and backhaul and wide area and local area is disappearing. That you need to rethink that whole. Unless we rethink that whole network topology issue, and I don't think virtualization is going to be a way forward. From an RF perspective, I see that we've solved the problem. You've got to somehow deliver that. You've got to deliver in-band and out-of-band performance. You've got to get out of that trade-off between in-band and out-of-band. So you improve your in-band throughput, you worsen your out-of-band performance. I can only see that happening in the spatial domain. Therefore, we have to go to fractional beamwidth antennas.
Yeah.
I guess we're running out of time here. We're going to lose people, aren't we? So, I agree. It's deterministic. So, Peter, can I suggest that Maury and Upker and me, we can carry on all night. I can see this becoming an all-nighter. So, I think for the sake of sanity for all our other people who will begin to depart in droves, we better say thank you and best efforts for the rest of it.
I think that's right. Thank you, everybody, for attending. Thank you especially to our presenters, Jeff, John, and Martin. Again, we certainly hope you will join us in investing in and becoming co-funders. Again, go to collaborata.com. We hope to get you all a recording of this soon as well to share with your partners and others you think might be interested in, so we can get this really, as I can see, interesting, intriguing, critical project funded. With that, everybody, thank you. We all hope to talk soon.
Thanks very much. Bye.
Thank you.